The air conditioning compressor is at the heart of the air conditioning system. The compressor is the pump that moves the refrigerant through the system. The compressor pulls the superheated, low-pressure vapor from the evaporator through the suction side of the compressor. In the compressor, the pressure is raised and the refrigerant is discharged through the outlet side as a high-temperature, high-pressure gas. The gas is pushed from the compressor to the condenser. The gas enters the condenser at the top and passes through a series of coils. As the temperature of the coils is higher than the outside air that is passing over the coils, the heat of the gas is released to the atmosphere. As there is a temperature change, there's also a change in the state of the refrigerant from a high-pressure gas to a high-pressure liquid. The high-pressure liquid refrigerant leaves the lower condenser and goes to the receiver dryer or the accumulator, depending on the system. While similar in function, the receiver dryer and the accumulator are somewhat different. Receiver dryers are located between the condenser and the evaporator on systems that use a thermal expansion valve as a metering device. The receiver dryer is used to store excess refrigerant to ensure a continuous supply. Receiver dryers use a desiccant or drying agent to purify the refrigerant. Accumulators, though similar in function, are located on the outlet side of the evaporator. The accumulator is used to trap excess liquid refrigerant and prevent it from reaching the compressor. Accumulators are used on systems that use an orifice tube as an expansion metering device. The high-pressure liquid from the compressor is metered either through the thermal expansion valve or an orifice tube to provide the refrigerant necessary to cool the interior of the car. The metering devices, whether expansion valves or orifice tubes, are restrictions. The high-pressure liquid is turned into a low-pressure liquid mist as it is forced through the metering device and onto the evaporator. The evaporator inside of the car is the main heat exchanger in the air conditioning system. Air from inside the car is blown over the fins of the evaporator, where the heat is transferred to the refrigerant passing through the coils of the evaporator. As the low-pressure refrigerant inside the evaporator absorbs the heat from the air, it boils. The refrigerant is changed from a low-pressure liquid mist to a low-pressure gas. The refrigerant is pulled from the evaporator outlet through the suction line of the compressor. On vehicles equipped with an accumulator, it passes through the accumulator on the way to the compressor. Once back at the compressor suction port, the cycle starts again. The movement of refrigerant from the compressor to condenser to receiver dryer, through the metering device to the evaporator and back to the compressor is known as the refrigerant loop. The refrigerant lines connect all the components of the air conditioning system. Refrigerant lines can be made from copper, steel, or aluminum. Hoses are usually made from synthetic rubber covered with a nylon braid for strength and have an inner nylon lining to prevent system contamination from degrading rubber. The types of hoses, fittings, and the O-rings that are used to seal them differ between systems that use R134A and systems that use the older R12 refrigerants. There are two common refrigerants used on today's vehicles. The properties of refrigerant R12 made it the refrigerant of choice for automotive systems for the first 50 years. R12 was very good at withstanding high pressures and temperatures without degrading or decomposing. It was considered ideal for automotive applications because it worked at relatively low operating pressures and was very stable. R12 systems used mineral oil, carried in the refrigerant, to lubricate the compressors. Refrigerant R12 is a fluorinated hydrocarbon that was found to be detrimental to the ozone layer of the Earth's atmosphere. Beginning in 1994, automobile manufacturers began phasing out the use of R12. By 1996, all vehicles sold in the United States were equipped with a new refrigerant called R134A. R134A has many of the same properties as R12, but is not detrimental to the ozone layer. R134A systems require the use of a different lubricant called a PAG oil. PAG oils vary by system manufacturers. Refrigerants R12 and R134A must never be mixed, as the refrigerants and their lubricants are not compatible. Because of the concern for the effect of R12 on the ozone layer, refrigerant recycling and recovery technology evolved. Refrigerant should never be vented directly to the atmosphere. To properly service an air conditioning system, shops today use refrigerant and recovery stations. The fittings for the R134A systems are different from those used on the R12 systems to prevent unintended intermixing. The operation of the air conditioning system is dependent on the principles of pressure and temperature. To troubleshoot problems with the refrigerant system, then, is to use the right tools to measure both temperature and pressure. When servicing automotive air conditioning systems, it is imperative to follow all of the safety precautions in the manufacturer's service manuals. Always wear safety glasses when working around systems under pressure to avoid the possibility of eye injury. And always wear gloves, as components can be hot. Additionally, refrigerant contact with the skin can cause frostbite. Pressure gauges to measure the pressures on the high and low side of the system will give a quick indication of how the refrigerant is flowing through the system and identify possible problems with components. Electronic leak detectors can be used to find the source of refrigerant leaks, as can fluorescent dyes that can be added to the refrigerant charge and show the leaks when exposed to a black light. And lastly, digital multimeters and scan tools are indispensable when troubleshooting the controls and system protection devices that we will look at in the next presentation. In this presentation, we've taken an introductory look at the principles of heat, temperature, and pressure that govern air conditioning system operation, the components that move the refrigerant through the refrigerant loop, and the changes in pressure and temperature, as well as the changes in the state of the refrigerant as it transfers heat from the passenger compartment to the outside air. Lastly, we introduced you to some of the shop equipment you will become familiar with as you both verify and troubleshoot automotive air conditioning systems.